faster than space-time can track, the fabric of our universe may tear apart, and this prospect alarms me. Our night sky is rapidly changing, perhaps beyond recognition, in a matter of decades or even just years. Astronomers around the world are sounding the alarm, with renowned experts like Neil deGrasse Tyson recently confirming some troubling news. Polaris, the North Star, is on the brink of exploding, signaling a potentially catastrophic development. For centuries, Polaris has been a steadfast beacon, guiding astronomers, pilots, and sailors alike. But this reliability may soon vanish, altering our perception of the night sky forever and affecting celestial navigation in ways we can't yet fully comprehend. Join us as we uncover the gravity of this impending threat and its implications for humanity. Let's dive into the story of Polaris as it nears the end of its journey. Polaris has long been revered as a guiding light, playing a central role in human history for astronomers and navigators. Its consistent position in the night sky has been crucial for navigation using the stars. However, recent research presented by the prestigious Royal Astronomical Society in September 2023 has raised doubts about the fate of this celestial guide. Polaris now wavers on the brink of explosion, threatening to disappear from our skies forever. Before we delve into the consequences of this revelation, let's explore Polaris itself. Known as the North Star or Pole Star, Polaris holds a special place in the sky due to its proximity to the celestial North Pole. Positioned directly above Earth's North Pole, it appears almost immovable in the northern sky. Located in the constellation Ursa Minor, Polaris shines as a moderately bright yellow-white supergiant star, far larger and more luminous than our Sun but much farther away. Although it is often viewed as a solitary star, Polaris is actually part of a complex triple star system. Its primary components, Polaris A and Polaris B, appear as a single entity to the naked eye, with a third companion, Polaris C, orbiting the binary pair. The gravitational interaction among these stars shapes their orbits and influences their behavior, affecting their brightness and other characteristics. Disruptions to these dynamics could lead to unpredictable variations in Polaris luminosity or pulsation patterns. Despite our understanding of Polaris complexity, much remains unknown about the intricacies of its stellar relationships. What we do know is that light from Polaris, located roughly 323 light-years away, takes time to reach Earth. This means the light we see from Polaris today actually began its journey centuries ago. Therefore, if Polaris were to explode now, we wouldn't witness the event for more than 3 centuries. The significance of Polaris transcends scientific knowledge, resonating deeply across cultures and civilizations. Its steadfast position near the celestial North Pole has endowed it with cultural, navigational, and symbolic meaning throughout history. Polaris has served as a guiding light for ancient sailors and explorers, helping them navigate vast oceans and lands. Its symbolic importance spans various societies, representing stability, guidance, and constancy amid the ever-changing night sky. In the realm of astronomy, Polaris' fixed position has been invaluable, providing a reliable reference point for celestial observations. However, with its uncertain fate looming, the loss of Polaris would not only reshape our understanding of the night sky but also diminish a cultural and navigational cornerstone that has guided humanity for centuries. Polaris has also been a key reference for studying the movements and patterns of celestial bodies. As a Cepheid variable star, Polaris exhibits periodic variations in brightness, which have led to important discoveries about stellar properties and the nature of variable stars. This characteristic has also played a crucial role in determining cosmic distances and calibrating instruments. However, recent observations have revealed a deviation from Polaris' usual behavior. Instead of following its regular, predictable pulsation pattern, Polaris has begun displaying erratic cycles of dimming and brightening. This anomaly has puzzled astronomers, prompting closer scrutiny of this stellar inconsistency. The lengthening of Polaris' pulsation period, traditionally stable in its cyclic dimming and brightening, can be attributed to interactions within its star system. Observations indicate an annual increase in pulsation length by 4 to 5 seconds, a significant phenomenon. While some astronomers attribute these changes to gravitational interactions among the Polaris stars, which affect its atmospheric conditions, Others speculate that the star may be nearing the end of its life cycle. Comparisons with Betelgeuse, another enigmatic star exhibiting similar luminosity fluctuations, have heightened concerns about Polaris' future. Betelgeuse's behavior has led to speculation about a potential imminent explosion, drawing parallels with Polaris anomalies. Red supergiants in their twilight stages often display such irregularities before reaching the final stages of their life cycles. Polaris observed inconsistencies align with behaviors indicative of stars nearing the end of their cosmic journey. However, definitive signs of Polaris approaching its ultimate phase remain uncertain. If Polaris were to go supernova, it would likely result in a spectacular event in our sky, possibly outshining the moon and becoming one of the brightest objects visible for days, weeks, or even months. The star's appearance would undergo dramatic changes, marking a significant event in astronomical history. If Polaris were to undergo a cataclysmic event like a supernova explosion, it could transform into a bright point of light or a transient object, possibly displaying vibrant and colorful hues before gradually fading away. Such an event would likely be visible to the naked eye for an extended period, potentially surpassing nearby stars in the night sky. The visual spectacle could temporarily alter our perception of familiar constellations like the Big Dipper or Ursa Minor, as Polaris is currently the North Star and an integral part of these celestial arrangements. However, despite the dramatic display, Earth would likely remain safe from any direct impact. Given Polaris' vast distance from our planet, any effects on Earth's climate or surroundings would probably be minimal. While the event would undoubtedly capture the attention of astronomers and observatories worldwide, the specific visibility and impact on Earth would be far less significant compared to a closer supernova event. As for Polaris' eventual fate, it's important to note that Polaris' destiny likely does not involve a supernova. While massive stars typically end their lives in a supernova explosion, Polaris is not massive enough for such an outcome. Instead, when Polaris exhausts its nuclear fuel, it will shed its outer layers and transform into a white dwarf, a peaceful end to its stellar journey. A white dwarf is a small, extremely dense stellar remnant formed from the core of a star after it has depleted its nuclear fuel and undergone gravitational collapse. These remnants are composed mostly of electron-degenerate matter, with a mass comparable to that of the Sun but compressed into a much smaller volume. Despite their high density, white dwarfs emit very little light and gradually cool over billions of years, eventually becoming faint objects known as black dwarfs. Polaris' transformation into a white dwarf marks the end of its active phase as a star. While it may no longer shine brightly in the night sky, its legacy as a guiding light and celestial reference will endure for generations to come. In the future, serves as a powerful reminder of the vast and ever-changing nature of the universe, where stars undergo dramatic transformations throughout their lifetimes. A white dwarf is the remnant of a low to medium-mass star that has exhausted its nuclear fuel. It is incredibly dense, with a mass comparable to that of the Sun, yet compressed to the size of Earth. This occurs when the star depletes its fuel for nuclear fusion and collapses under its own gravity. Once a star becomes a white dwarf, its remnants are nearly invisible to observers on Earth, a fate that could eventually befall Polaris. By drawing comparisons between Polaris' anticipated transformation and past supernova events, such as SN 154 or SN 1987A, scientists gain valuable insights. These comparisons allow for the analysis of phenomena like nebula formation or cosmic ray emission, as well as similarities in glow variations, element emissions, and their impact on surrounding space. This provides a foundation for understanding the potential consequences of Polaris' future changes. Comparing Polaris' possible outcome to observed supernovae like SN 2011 Fe or SN 2014 J could yield critical data. Analyzing light curves, spectra, and the remnants from these events helps scientists project similar traits for Polaris' predicted burst, aiding in predictions about the evolutionary stages of its resulting stellar remains. To create a definitive comparison, researchers examine differences in mass composition and the velocity of ejected materials between Polaris' potential outburst and other known events, considering whether its explosion might lead to the formation of nebulae or unique elemental distributions. This further enhances our understanding of its distinct characteristics. In addition, evaluating the pulsational variability of stars nearing their end stages, such as Polaris, against observed supernova progenitors allows astronomers to identify similarities or deviations. These comparative studies contribute to understanding the potential burst mechanism of Polaris and refine predictions about its future. Despite careful observations and extensive research, astronomers remain puzzled by the irregularities in Polaris behavior. The mysterious nature of these erratic pulsations calls for deeper investigation into the underlying mechanisms responsible for this stellar anomaly. Unraveling the unique conditions that drive Polaris irregularities holds the key to advancing our understanding of stellar evolution and behavior. While Polaris serves as a steadfast guide for telescope calibration and celestial navigation, the possibility of its explosion presents significant concerns. Such an event highlights the need for further study and analysis in the field of astronomy. Recent findings by the Royal Astronomical Society have revealed a new area that demands intensive study: the enigmatic behavior exhibited by Polaris. This underscores the critical need for further investigations and dedicated research efforts. Astronomers must grapple with the complexities surrounding Polaris' unpredictable pulsations, recognizing the need to untangle the unique conditions triggering this unusual activity. However, the definitive answer remains elusive, and only time will reveal the truth. In the meantime, advancing our understanding of the fundamental mechanisms shaping Polaris anomalies is crucial. If Polaris were to undergo a catastrophic event, such as an explosion, the loss of this vital celestial reference point could significantly impact the accuracy of ground-based telescopes and celestial measurements. This would necessitate the recalibration of instruments and could potentially affect the precision of astronomical assessments, representing a critical loss for the field. Indeed, Polaris' atypical behavior has exposed a realm of uncertainties in the astronomical world. The looming possibility of its imminent explosion calls for heightened vigilance, focused research efforts, and a concerted attempt to grasp the unique stellar complexities driving its erratic conduct. As we contemplate Polaris' fate, it's essential to understand its broader context within stellar evolution. Stars like Polaris serve as vital laboratories for studying the life cycles of celestial bodies, helping scientists understand how they form, evolve, and ultimately end their existence. The study of such stars allows astronomers to refine models of stellar dynamics and gain a deeper appreciation for the forces at play within these titanic structures. Polaris, a Cepheid variable star, plays a crucial role in establishing the cosmic distance scale. Cepheid variables are known for their predictable brightness fluctuations, which correlate with their intrinsic luminosity. This relationship allows astronomers to measure distances to far-off galaxies, anchoring the ladder of cosmic distances. The potential end of Polaris thus raises questions about future measurements and our understanding of the universe's expansion. Furthermore, studying Polaris' upcoming changes could provide new insights into the behavior of other stars nearing the end of their lives. By observing its characteristics and phenomena, astronomers could uncover patterns that apply to a broader class of stars, particularly those transitioning from the main sequence to their final stages. The lessons learned from Polaris could inform our understanding of other supernova progenitors, helping scientists predict the behavior of similar stars before they explode. Beyond its scientific significance, Polaris holds a unique place in culture and history. Its prominence in various myths and navigation practices underscores its importance to civilizations around the world. Sailors have relied on its steadiness for safe passage, while countless stories and legends have been woven around its glow. Losing such a historic star would not only represent a scientific setback but also a cultural shift, affecting traditions that have endured for centuries. The potential transformation of Polaris into a white dwarf also invites a philosophical reflection on the nature of existence. In the grand tapestry of the universe, stars undergo cycles of birth, life, and death, serving as a reminder of the transient nature of all things. This reality raises questions about humanity's place within the cosmos and our ability to comprehend its vastness. Moreover, the aftermath of Polaris' explosion could lead to new discoveries about the interstellar medium. The ejected material from such an event would enrich the surrounding space with elements forged in stellar interiors, potentially contributing to the formation of new stars and planetary systems. The cycle of stellar death resulting in new life is a fundamental aspect of cosmic evolution. As we anticipate the future of Polaris, it becomes increasingly important for astronomers to continue monitoring its behavior. The use of advanced technologies, such as space telescopes and spectroscopic analysis, could yield crucial data that enhances our understanding of this iconic star.